Okay, so here we have our second normalization problem. This is actually a smaller table, but it's a little more complicated because we have more functional dependencies. So let's once again start with our rules. You always want to have these close by when you're normalizing tables, and of course you'll always be able to have those when you're normalizing for me on a homework or a homework assignment or an exam. So let's look at the rules here. Identify every functional dependency. Let's just, these have already been identified here, but let's just look at them really quickly. We have the skew, which is determining really all other columns in the relation. Same thing with the skew description. If you look at this, you read them closely, they are actually unique top to bottom, and therefore determining all other columns in the relation. So those are going to be candidate keys. Because by definition, a candidate key is a column that will determine all other columns in the relation, be a candidate for the primary key. We also have buyer determining department as well as budget code. So if I said, what's Pete Hansen's department? You could tell me without a doubt every time that Pete works in water sports. And if I say, what's Pete Hansen's budget code? You can tell me without a doubt that it's always going to be BC 100. Okay, same thing with Nancy and Cindy and Jerry. We can always get the department and the budget code just by the buyer's name alone. So we have a functional dependency there. We also have department itself determining budget code. So if I say, leaving the buyers out of it, what is the budget code for the water sports department? You would be able to tell me every time. Every time we see water sports in this table, we see the budget code of BC 100. Every time we see camping, we see BC 200, and climbing BC 300. So department alone also determines budget code. So there are our functional dependencies. Let's go back to the rules. Identify every candidate key. So we talked about these two. Skew and skew description are candidate keys for this table. Okay, so we have two candidate keys here. If there is a functional dependency that has a determinant that is not a candidate key, let's see where we stand. We have two functional dependencies that have determinants, buyer and department, respectively, that do not have, or that are not candidate keys. And so these are the culprits. These two functional dependencies are keeping our table from being in BCNF, that golden standard. So we have to go through the steps to break it all up, and we'll be systematic about it and start with the rules here. So again, I have typed up all the columns. I came up with a good name for my table. I'm calling it skew data. We have skew description, department, budget code, buyer, a complete table at the moment. And now we'll go through the normalization process. Okay, so step A, we're going to move the columns of that functional dependency to a new relation. So you're probably thinking, well, which one are we talking about? We have two, unlike the last example, we have two faulty functional dependencies, so which one? Well, you can take your pick. It really doesn't matter, but if you want to kind of move things along a little more quickly, always go after that functional dependency that has more columns involved. This one has 3 columns involved, buyer, department, budget code. And this one only has 2. So let's start with this one. And then we'll just work through the rules again for the second one if we have to. Sometimes you have to run through 2, 3, or more times to get a table fully normalized. Okay, so we're going to move these columns into a new relation. That would be buyer, department, and budget code. I have to come up with a name for my new relation, so why don't we call it, when in doubt, you can always do like a hybrid thing like this. This is fine. Okay. I want to point out here, notice that I have cut the columns from the original table, which is now considerably shorter, and I have moved them into their own table. Students often make the mistake of doing a copy, so they leave the original, the columns in question in both tables, and now you have major redundancy in your design, which is what we're trying to avoid by doing this. So, okay, so that's step A. We've moved the columns of the faulty functional dependency into their own relation. So step B, make the determinant of that functional dependency the primary key of the new relation. So that was the buyer. it's going to be the primary key of the new relation. So I'm underlining it. Back to the rules. Leave a copy of the determinant as a foreign key in the original relation. So I jumped the gun on taking buyer out. That's okay. I'll put it right back in. And it is a foreign key, so I'm going to italicize. Okay, almost there. Create a referential integrity constraint between the original relation and the new relation. So as I said, always start with the foreign key. The foreign key in this case is in the SKU data table. So we'll say SKU data.buyer must exist in buyer department.buyer. Okay, so you may be tempted to say at this point that we're done. But look at the rules here. 4. Repeat step 3, meaning all this that we just went through, until every determinant of every relation is a candidate key. So, I did solve one problem to some extent by going through that normalization process, but I still have a problem here because in this new table that I've created, I have a determinant, which is department here. I can't forget about this functional dependency. Department determines budget code. So I have a determinant that is not a candidate key. Department is not unique here in this case. So it's not a candidate key. And besides, it's not determining all other columns in the relation. It's only determining budget code. So that's really the main thing we have to go by. So what we have to do is just go through the normalization process with these as well. So let's come up with a brand new table. Let's take it from the top here. We're going to move the columns of that functional dependency to a new relation. Come up with a new table name. We'll just call it department. And we're going to take the faulty functional dependencies out of the original table. Here we go. Okay, so that was step A. Make the determinant of that functional dependency the primary key of the new relation. All right, so that would be department. We'll underline it as the primary key because that was the determinant of the functional dependency. It is now the primary key of our new relation. We jump the gun, so we have to leave a copy of the determinant as a foreign key in the original relation. So let's go back to buyer. And we have to add department. I have to do something about that underline here. I'll get rid of that. It is a foreign key. So I'll italicize it. Okay, and then lastly, our referential integrity constraint. So I start with the foreign key, so that would be buyer, department, must exist in department. Okay, so we actually started with a very small table, not a lot of columns, and we ultimately had to break it up into 3 even smaller tables to be fully normalized in BCNF. You may think, why bother? The table was so small to begin with. Now we have an even more complicated design with the foreign keys all over the place. But really what we've done in doing this is our design, this data, should be immune to modification anomalies, meaning the insert, update, and delete modification anomalies. So that is why we try to get into BCNF as the standard for our databases.